Hello, my friends. I'm Clover. This is Genuinely Approachable Sudoku, and today we're solving a puzzle called The Fellowship of the Ring by Philip Newman. This was posted in the Gas channel on January 3rd, 2025, and I found this to be an especially approachable Sudoku, even by our relatively approachable Sudoku standards. I found this one to be pretty gentle. This is a good one to try if you are very much a beginner to the variant Sudoku world. So even if you don't always give these puzzles a shot yourself, this would be a good one to pause this video and have a go at on your own, and leave me a comment if you succeed in solving it. So this is an XV pair Sudoku. So we have to place the digits 1 through 9, once each in each row, each column, and each outlined 3x3 region. And in addition to that, there are some X's and V's marked in the grid. Digits that are separated by an X will sum to 10, and digits that are separated by a V will sum to 5, as in Roman numerals. Not all of the possible X's and V's in the grid have necessarily been given, so it is possible that there will be other pairs in the grid that sum to 5 or 10 that don't have an X or V marked between them. So we're going to start with the X's that already have a digit marked on them. We're going to kind of follow those through. So 3 plus 7 is 10, 7 plus 3 is 10, and 3 plus 2 is 5. 4 plus 6 is 10, 1 plus 9 is 10, 9 plus 1 is 10, 1 plus 4 is 5, and 2 plus 8 is 10. Now I'm going to move to these V's, because these are now fairly restricted. Neither of these digits can be 2 or 3, so this actually has to be 1 plus 4, making this 2 plus 3, because those are the only two possible ways that one can make 5. This is even more restricted because this cell sees 2, 3, and 4, but in order to be part of a sum that goes up to 5, both of the digits have to be 4 or less, so this can only be a 4. And that resolves this. Similarly, this one sees a 1, a 2, and a 4, so that will be a 3. Which resolves this, and that gives us some more digits that are sitting on X marks. Now, that leaves us with 5, 7, and 9 in the central row. You don't have to mark that right now, but I'll do it just to remind us that that is what we are working with. Now, the next thing I'm going to do is figure out what's going on with these 10 sums. Actually, no, it's not. I'm actually going to work out some of what's going on in these two regions first to make it easier to resolve these guys. So let's go ahead and do that first. So here we can't do 6 plus 4 in any of these positions. So each of these has to be either 1 plus 9, 2 plus 8, or 3 plus 7. This can't be 2 plus 8 because it sees a 2. So that's going to be 1 plus 9 or 3 plus 7. So that's not a 1, that's not a 9, and so that's not a 1. That's also a 3, 7, or 9. This can't be a 3 because there's a 3 right there. This pair here, this cell has to be greater than 5, or 5 or greater, because it sees 1, 2, 3, and 4. Can't be 5 because 5 can't go on a 10 sum. So this has to be 6, 7, 8, or 9, but we're going to reduce it even more than that, because we have a 1, a 2, and a 3 up here already. So this can't be 1, 2, or 3, it must be 4, making that 4 plus 6. Something similar going on down here. This cell can't be 1, 2, 3, or 4. It can't be 5 because it's on a 10 sum, so this has to be 1, 2, 3, or 4. Therefore, it is a 2 because there are already 1, 3, and 4 in the row. So that's going to be 2 plus 8. That gives us some stuff we can fill in. We have two 6s here. They see all of these cells, therefore I need to put a 6 here. And that 6 sees all 3 of these cells, so I need to put a 6 here. Similarly, I have two 8s here. They see all of these cells, so I can place an 8. That 8 sees all 3 of these cells, so I can place an 8 right here. That's the only position that's possible for 8. Now I have two 8s in these columns that see these cells, so that's an 8, which makes this a 2. And I have two 6s here, which see these cells. One of these has to be a 6. I was a little sloppy over on the right side earlier. I did more work on the left side than the right side. But for the same reason as on the left side, this can't be a 6 because it would have to get paired with a 4. So that's going to be my 6, and that is going to be my 4. Now the next question I'm going to ask myself, just glancing at this, is where do some of our 1s go? So I have 1s here and here, and I have a 1 right there. That is going to combine to see all 8 of these cells in this lower area, except for, I mean, these guys are already full. So this has to be a 1, which resolves this into 3 7 pairs. And these are now going to be 1, 5, and 9. That can't be a 5 because it's on a 10 sum. It can't be a 1 with a 9 because there's a 1 in the region, so this has to be a 1 here and a 9 here. And that eliminates 9 from that cell. All right, now where are we going to put, what is our next digit that we're looking at up here? We need to put a 4 in the bottom right. There's going to be a 4 there. Okay. We need to place a 3 in the top right. There's a 3 there. There are 3s here and here. That places a 3 right there. That tells us that this sum can't have a 2, a 3, or a 4 in it, so it has to be 1 and 9. That makes this a 9. That's going to resolve this pair into a 5 and a 9 in this order. And we also now know that this pair, summing to 10, can't have a 1, 2, or 4 in it, so it will be 3 plus 7, and that fixes the middle row. That's now going to be a 6 to finish the region, and that's an 8. This is now a 5 to finish off its row, and now this column is nearly complete. It just needs a 7. This region only needs a 5. Now, let's look up here. In this column, we only need a 5 still, and to finish the region, we only need a 1 and a 7, which are resolved. Here, we only need a 5 to finish the row. Here, we're going to need a 2, a 5, and a 9. This will be a 9 because there's only one digit remaining in the column, and we have a 2 and a 5 because there's already a 2 in column 2. That's going to be a 5 to finish the column there. And here I need a 3 and a 9, which will get arranged like this. That's now a 5 to finish the row. This pair is going to be 6 and 7, which resolve based on what I already have in the columns, and this pair is going to be 8 and 9, which also resolve based on what I have in the columns. Now to finish the grid, I just need 4, 6, and 7 up here. There's a 4 and 6 in this column already, there's a 6 and 7 in this column already, and that's a 6, and then we're going to finish each of these rows with a 2, a 9, and an 8, respectively. And that is how you solve Philip Newman's The Fellowship of the Ring. Hope you enjoyed that one. Solve it yourself by checking out the link in the description below this video, and I will see you again in 3 days.